Good morning, class. Welcome back to geometry. We're scoring lessons 67 and 68 this morning. So if you have not finished 67 and 68, please push stop and finish it. Finish it before you listen to this, before you score the homework with this video. All right, lesson 67. Number 1, find the area of this regular pentagon to the nearest tenth. If you use the formula on lesson 66, from lesson 66, you should find 4,836.3 centimeters squared. Again, 4,836.3 should be your answer for number 1. Number 3, find the value of x in the figure. If you use the formula that we found in lesson 64, and that is to say 1/2 of 86 plus the other one, and you find 180 minus 63 will give you 117. So 1/2 of 4x positive 8 plus 186 equals 117. That should be your setup, and x equals 10. Number 3 is x equals 10. Number 5, find the perimeter and area of a regular octagon with 30-foot long sides and an apothem that is 36.2 feet long. The perimeter should be fairly simple. 30-foot sides, octagon 30 times 8, 240 for the perimeter, and then the area would be 4,344 square feet. 4,344 for the area. Number 6, what type of transformation takes square stub to square stub prime, so to speak? What type of transformation? Is it a translation? Is it a rotation? Is it a reflection? The way that you tell is look at the order of the vertices, and that simply has been slid over to the right. All the vertices are still in the same order, so it's a slide or a translation. That's the term. Translation or slide for number 6. Number 8, determine whether the quadrilateral at right must be a square. Must that quadrilateral at right be a square with the information given? What's given is that this side is congruent to this side and there's a 90-degree corner in the diagonals. Is that enough to say it's a square? The answer is no, because it could be a rhombus. Remember, properties of a rhombus, they have perpendicular sides. So it does not have to be a square. Number 14, identify the type of transformation that takes this triangle to triangle EFG prime, E prime, F prime, and G prime. Look carefully, is it a reflection, rotation, translation, or a rigid transformation? The answer is A. It is a reflection. If you look carefully, it is not a rotation. If it would be a rotation, the order of the vertices would be changed. The hypotenuse would be on the other side. This has simply been flipped on a 45, kind of like a 45-degree line is the line of reflection, and it's been flipped across that, reflected across that. Number 15. Which of the following scenarios describes a random event? And then explain why geometric probability cannot be used for the other. This one is maybe a little bit of a funny question, and I let it in here for discussion, but we can't have discussion with this format. So, a tennis player hits a ball to the opponent's side of the court. Is that a random event? Well, it might be. Depends on your tennis skills. It might be for me. It might be random, totally random where that ball is going to go. It could go this way, it could go that way, it could go the other way. But generally speaking, no, because you're aiming for a certain spot, so it's not totally a random event. Again, it's based on the skill of the tennis player. B, an astronomer scans the region of the sky looking for meteors. I would again say that's not random, because you're going to be looking for a spot that maybe he's not looking for a certain spot in the sky, he's just scanning. So he's just opening up, he's just looking at the sky, the whole sky, looking for meteors. And then you say, yeah, it's a random event because meteors are equally likely to occur in any given portion of the sky. That is what the score key says. I don't necessarily agree with that, because most of the times when there's a meteor shower coming up and you can get directions about where to look, you say, you look to the northwest and it's going to be in this segment, this quadrant of the sky is more likely. So I would sort of say none of those, but according to the book, they like B. B would be a random event. Don't count that one wrong, whichever answer you put, because you could probably make an argument for both, and it would be interesting to hear your arguments. I can hear you arguing now, especially Robbie. Sorry, Robbie, couldn't resist. 16, question 16. Trapezoid is formed by the midsegment of a triangle as in the diagram shown. Find a formula for its area in terms of its height and its longer base. Okay, normally we say 1/2 of base times height. But if you rearrange that equation, and actually if you solve for it in terms of height, so area is 1/2 of base 1 plus base 2 of the height, and you can rearrange and work it, and it becomes 3/4 of base times height. Again, that one might be a little difficult, but 3/4 base times height. That's the formula for the information given. That's kind of rearranging that formula if you just know the bottom side and you don't know the other one. Number 22. A certain isometric transformation is performed twice, and the resulting figure is in the same location as the original figure. What type or types of transformation could this be? So the same transformation happened twice. You did it one time and then you did it again, and you ended up at the same location as you started. So what type of transformations could it be or not be? Well, again, you have to do the same thing twice. So it could be a reflection. You could simply rotate it 180 degrees, from any point. You could rotate it from this point down here and rotate it 180 degrees, and then from that same point you rotate it 180 degrees again, and it'll come back exactly where you started. You could also reflect it across a line, or reflect it again. It could not be a translation, because if you slide it and then slide it again, you'd end up over here. Now actually I would say that for the reflection as well. So really the book says reflection or rotation. I would simply say rotation by 180 degrees would be the one that you could do and do twice and end up at the same place. Now we could argue about that one again. I don't know for sure what you all are thinking, but let's say that reflection, the book says reflection or rotation. I would like to argue that just a rotation by 180 degrees is the only one that you could do, because you're ending up at the same location. Alright, let's move on. 23, reflect quadrilateral PQRS across line N, and it's going to be difficult to draw, but it looks like this a little bit. P, R, Q, and S, and then the line comes in here like this. This is line N, and you need to label the vertices so that you know for sure you're just going to reflect it across that line. So you simply start with the same distance away from the line. That's point R, and then it goes like this a little bit, and that's point P. Then it comes in a little bit, and that's point Q. It gets in the way, comes over here. Well, this S should end up about the same distance F, so like that. But again, my drawing is bad. As long as and you should mark these primes. So R, P, R prime, P prime, Q prime, and S. Of course, it's not real accurate and not real nice, but that's the general gist. You're just reflecting it across the line. So something like that is what you should get for 23. All right, number 29. To the nearest tenth, find the area and perimeter of an equilateral triangle with sides that are 32 feet long. The equilateral triangle, 32 times 3 is 96, so the perimeter is 96, and the area is 443.4. 443.4, it says, to the nearest tenth. Again, you're going to use that formula. The area is 1/2 of the apothem times the perimeter. And you'll use that 32 to find the top. We did that before, I think. All right, let's go to lesson 68. Lesson 68, number 3. It is unsafe to lean a ladder at less than 70-degree angle with the ground. If a ladder is 8 feet tall, at least how far should the ladder be from the wall to the nearest 100th of a foot? This is trigonometry at its best. Safety here. OSHA probably put that statement in there, that question in there. But an 8-foot ladder leaning against the wall. Here's a wall. Here's the ground. Here's an 8-foot ladder. That's kind of steep. Most times ladders are something like this. That's an 8-foot ladder. And they say it must be at least 70 degrees here, or less than 70 degrees. If you make it smaller than 70 degrees, then it was out there like I did here, or this way, whichever way you want to think of it. If you go too far this way, it'll fall this way. If you go too far like this, it'll fall down flat. 70 degrees is a magic number. They want to know this distance right here, how far away from the ground, so our wall doesn't go down on the ground like that. It's not subterranean. That's the ground. What is this distance? Let's call it x. And we need to find out what this distance is. This is sine, cosine, tangent information or territory. So your memory aid, this is how I would do it whenever you're coming up to a problem like this. Just write it, the 3 out here. So Oscar, head, egg, hold, on, Arthur. And this is sine, cosine, and tangent. those are your three, and now you're going to decide which one of these you need to use, and which one do you need to use. You're looking at it from this angle, so you're talking about a hypotenuse, and you're talking about this one, which is adjacent. So your two letters you're looking for are hypotenuse and adjacent, and it looks like it's this one is what you need, because that's the only one with the A and an H. So use that information to write a formula. The cosine of a 70-degree angle, the cosine of a 70-degree angle is equal to adjacent over hypotenuse. Did I do that right? Yes. So solve for x. That's an x right here. Solve for x. And since it's divided by, you take everything times 8. So, and in this case, you can go ahead and use this, punch this into your calculator and turn this into a decimal number if you want, or just let it here for now and work on it later. It doesn't matter when you do it. Right now I'm just going to move this 8 over, so it's 8 times the cosine of a 70 degrees equals x. And then take your calculator, I don't have mine now, but cosine of 70 degrees equals some number, take that times 8, and that'll get you x. You should get 2.74. 2.74 for the distance. Because it has the nearest hundredth of a foot, so you round it, x equals 2.74. That is using your calculator to evaluate that expression. What's the cosine of a 70-degree angle? Some fraction number times 8 will give you that answer. Hope that makes sense. Number 7. Write expressions for the values of the sine of q, the cosine of q, and the tangent of q in this figure. Again, you could use this information here. We'll leave it up. And it's a little bit, I skipped this problem in the lesson, but it's there. It's kind of like you're doing this. It's not quite using the same thing. It's not quite using it as far as it is to use side length like we just did, but it's simply practicing using this. So the sine of q, and this is q, r, and s, and this is a, b, and c. So the first question, it says write expressions for the values of the sine of q. The sine of q is opposite over hypotenuse. Opposite is a, hypotenuse is c, so the sine of q in this case is a over c. Sine of q is a over c, the cosine of q is b over c, and the tangent of q is a over b. If you use these carefully and just use these as the side lengths, that will tell you what it is. Sine of q is a over c. I'll write it out. Cosine of q is b over c, and the tangent of q is a over b. Again, you're getting it from this list. Tangent of q is opposite over adjacent, so a over b for this tangent of q. All right, number 13. Elias is trying to find a coin he dropped in, which rolled into a dark rectangular room. What is the probability he will find the coin within 1 foot of the wall? I don't like this problem, but assume it's just equally likely to go anywhere on this floor. Again, probability, the way you think of probability is what the outcome you're looking for divided by the total possible outcome. The total possible outcome is 80 square feet. That's the whole room. It could go anywhere in the whole room, we're saying, equally likely to go anywhere in there. So 80 square feet is the bottom, and then what is the top? You need to find the square feet in that dashed line, the outer edges there, that perimeter. And if you do that correctly, you would say, let's see, find it here, where are we at, 13. Total area is 80 square feet. The area that's all 1 foot from the wall, the total is 32 square feet, and that's actually bigger than what you would think just looking at it. But 32 over 80, so 32 over 80 is his probability. Now you could reduce that a little bit, and you probably should, but if you reduce it to a fraction, it's 2 over 5, or 0.4, or 40%. 40%, 0.4, 2 over 5, 32 over 80. Those are all acceptable. I like percentages like this. He has a 40% chance of finding it in that dashed line, or it's 40% chance that it went in there. Probability is simply the area of your desired outcome divided by, your desired outcome divided by the total possible outcomes. The total possible outcome is the whole room is 80 square feet. Your desired outcome, what you're looking at, is 32, so 32 over 80, and go from there. 17. Is the following a valid application of the law of detachment? Explain. All birds have feathers. A whale is not a bird, therefore a whale does not have feathers. Now, we know that whales don't have feathers, but just because the back statement, the last statement there is true, doesn't mean that we arrive there logically. So it's asking, is it a valid application? Well, it says all birds have feathers, but it does not say that only birds have feathers. And that's what would be needed. If it would say only birds have feathers, then they say a whale is not a bird, therefore a whale does not have feathers. That would make logical sense, but it doesn't say that. It just says all birds have feathers, but there may be other animals or other things that have feathers. So no, it is not a valid application. And the reason it is not is because it does not say that only birds have feathers. All right. Number 20. Rectangle NMOP is rotated clockwise about point Q. Explain why and now this gets tricky. You have to actually draw it out, and then you're combining parts of the original triangle with parts of the original rectangle with parts of the rotated rectangle. And the reason is the vertex angles both measure 72, the base angles each measure 54, and so by definition of angles and asimilarity, the triangles are similar. It's really like you're rotating it, and every part on this thing you rotate this way, then you combine those. It makes sense if you draw it out, and we're going to stop with that. They did draw it out there for you, I guess, but you got to connect the dots with what they're saying. All right, 24. Which of the following is not a pair of equivalent functions in triangle ABC if C is a right angle? Again, this one you're going to have to probably have to draw it and then look at this list here that I left out, and we'll uncircle the cosine. But if you draw this draw a triangle ABC and C is the right angle, ABC, C is the right angle, and then it's going to ask for what are the equivalent functions. And you could label them. You could just say x, y, z are your lengths, or you could actually put numbers in there. It doesn't matter. You could make up your own numbers and 3, 4, 5, and then compare all this list. If you do that carefully, you will see that A is the only one that is not equivalent. B, the sine of A and the cosine of B, those are equivalent because you're changing your perspective, and so you come up with the same sides. Same thing for D and C, the same thing. That 1 over tangent of B, you just have to invert that as the inverse. And it's multiplying that fraction by 1, which you switch it around and so on. So A is the correct answer. A is the only one that is not equivalent. Hope that makes sense. I know I'm kind of rushing, but that's the way it is. All right, 28. Write the sine of M as a fraction and then as a decimal rounded to the nearest hundredth. So sine, Oscar had opposite over hypotenuse. Sine of M is opposite is 33, hypotenuse is 45, so 33 over 45, that's a fraction. Evaluate that around that, convert that to a decimal, and you get 0.73. That's rounded to the nearest hundredth. So the sine of M is 0.73. Number 30, which word best describes the transformation of ABC D into A prime, B prime, C prime, and D prime? Is it a translation, reflection, rotation, or none of the above? Look carefully, and it becomes apparent to me that it is a reflection. If you look at the order of the vertices, A goes the furthest away from the line, so it ends up the furthest away from the line. B flips across, D flips across, and C is the closest on both C and C prime. So reflection, letter C for number 30. All right, if you have questions, you can ask them. Score this and correct it, and tell me how many you got wrong.